Okay, now we're ready. Let me test it out. Okay, it's going. All right, let's get ready to design a toy car. I know you guys been waiting on this, and I've been waiting to just get it out myself. Just want to just get it out. So let's go ahead and do it, right? So let's design this darn thing. All right. So the four videos I can see coming down is no one escapes electromagnetics. Get ready to design a toy car. We got deeper design, learning for the toy car. We go into detail on the components. So if people want to learn that stuff and get kind of understand how it works, I highly recommend that one. But I can't put everything all onto one video. Then there's the EB update. So that's going down. Next four, maybe five. I don't know yet, but it's definitely four. Okay, we're gonna do the EE Manager says. That's on all my videos. The toy cars parts list. That's on all my, all the schematic and auto Chad. Auto Chad. Okay, the toy car code talk, the toy car bench test, the toy car on the road. I showed that. Eating the Mr. Beast and the thank you. That's just me. Hey, please more subscribers. Okay, and so let's go ahead and do it. And I'll see you on the next section.
Okay, so we're going to let's design a toy car. This is my second take, but okay. And this is the picture of my car that I did. And you see there's quite a bit of wires, but it would have been worse if I didn't do what I had to do. It would have been like a severe rat's nest, so I don't think it looks too bad. All right. Mr. Beast Feastful Chocolate. Yes. I I got this chocolate bar from I went down to Target. I got a sweet tooth, and I just heard of Mr. Beast. I think in April I signed up to a YouTube sort of like a coaching thing. I think it's vidIQ. It's something, and they just automatically subscribe to Mr. Beast. I mean, hey, automatically subscribe to other people like me. Okay, no, just no. Okay. Anyway, so I actually enjoy the Mr. Beast chocolate Mr. Beast show. I watch it, and it changed my life. Okay, so let's go on. This is the E-Manager part, and we're going to take this slowly because if I talk too fast, I start stammering. So I have to talk kind of slow it down. I had a lot of coffee. I'm like, whoa, So, in fact, I'm drinking coffee right now. Your car must be battery powered, okay? And it must have a battery powered. I'll show you what battery powered is. Pick your own battery. I got my own battery. The voltage is completely up to you, but I highly recommend getting a higher voltage. A power switch. Now the power switch is an automatic emergency power switch. Like in case it gets out of control, you just blam. You just get a switch, you turn it off. A few buttons for different operations. You can decide on what those operations are. One of the most important operation is the car must go forward and then backwards. So that's the most important operation. If you want your car to do something else, that's on you. But I got 3 buttons to kind of show the different modes. Must have speed control. So like on mine, one doesn't have speed control, the other one does, and the other one has speed control and goes backwards and forwards. This car is flexible, so it's like, just get some sort of chassis. You can make your chassis. It must have at least one DC motor. Okay. Mine has 4. I actually got it so that I had to do my own engineering for 4 DC motors, 1 for each wheel. And it must be at an embedded device. So let's just make it. Let's go ahead. And your embedded device, guys, I don't really care. Arduino. I don't care. I don't care if it's Raspberry Pi. Just put some sort of an embedded device and get your car to work. Okay. So I'm not okay. So for promotion, okay, I didn't get it, but the toy car shall have DC motors that uses PWM. So we talked about a little bit of PWM in some of my past videos. We'll go again, talk about it on some. I'll do a small lab how it affects the DC motor, and so I'll explain that a little bit. If you want to really know, I have an old video. I think it's a different kind of dimmer switch. Try that and just see if that might help. Okay, so then sensors that will prevent the car from hitting a wall. I didn't do that, but you can get ultrasonic sensors, you can get light sensors, anything that will kind of, and just hit the wall. And if you did that, hey, if you show me the code, that'd be awesome. Of course, that will probably not happen, but hey, let's be positive. Okay, let's go ahead and servo motors. It's I'm not going to explain. This is primarily about DC motors. The next video is going to be on servos and steppers, and so that's why I didn't include it. Okay, because I didn't want too much. To me, it would take a long time. But I hope you guys go the extra mile. Now, wireless remote control. Now, I didn't. There's no way I had time for that. But if you guys show it on the internet, don't just say, 10 best Arduino projects, and then just show the card. You guys are playing around with the card. No. Let's show it. I just went down to Amazon. I just bought the car. I didn't really do the project. I didn't get the promotion, but I did do the car, and I worked pretty hard on it. I worked on it for about a month, a little bit too long, I think. I'll explain why it went a little bit too long in later videos. And now that we kind of explain the game plan, this is let's go ahead, stop the video, design code, and build the project. So for people who want to get challenged, this is for those type of people. I think there are a few in my audience. Some are kind of learning as we go. Some are just curious. They're just engineering. They're just engineering curious. They're in the closet. They don't want to, they're afraid that people are going to make fun of them because they like engineering. But I won't tell anybody. It'll be our secret. Anyways, let's go ahead and let's go to the next section. I'll see you there. Okay, here we go. We're talking about my DC motor toy car parts list, and let's go through this. There's a lot on this list, and I'm going to talk about each one anyways. So it's best for you guys to take sort of like a screenshot of this and just kind of go down the list. But I'm going to describe each one as we go. So let's talk about this. Let's talk about the development board. I use the same Nucleo F411RE development board. It is gaining some popularity. Hey, how about that? How about that? You can use an Arduino. Arduinos are a little bit more expensive. They could be about $35, $50. This is only like $20. So that's on you when it comes to cost. So that's what I have. That's just your typical. They got all kinds of brands, but I'm not trying to isolate anybody. So the car chassis, I used a robotic car chassis with 4 DC motors on it. I got it in Amazon. It's like $25 or something like that. It doesn't really. I wish it had more of a turn base, but it only goes forward and backwards. So if you can. So if you can get a car that has a better swivel base, that's on you. But it was pretty cheap, So that's what it looks like. Comes with 4 motors and tires. That's what the chassis looks like. I think it's Chinese made. I don't know. Okay, so the next one this is a voltage converter. This is a 3.3 to 5 directional converters. I will discuss that a little bit later on, but that's what it looks like. I have used other converters. I had some issues with some other 3.5 converters. We'll discuss that in the troubleshooting section, and we'll discuss how to troubleshoot some of this stuff and what I do to troubleshoot, and maybe, okay. This is another DC to DC voltage converter. I'll explain why I use these, but this is what it looks like. It's an LM2596 DC voltage converter, and these have pretty cool LEDs, so if you can trim it down to 3.3 volts, 5 volts, and all that, these are pretty cool. These are, I'll explain why I use these instead of a voltage divider circuit. Okay, the battery, this is a 12-volt lithium-ion battery. I use this because I had the highest milliamp hours. So this is 12 volts. The batteries are very important for this. So I used that battery. It's a great battery, by the way. It's pretty rock solid. H-bridge. This is the L293D motor DC motor controller IC. This is a chip. We haven't used too many chips. So we're finally getting into some more external hardware, and I will explain that. But for right now, this is what it sort of looks like. This gives hopefully people a visualization of what it looks like. Okay, so this is it's a hardy chip, but don't take it. I'll explain how it works. IC sockets, these are good. You want to solder those things and put the chips on top. Very great for troubleshooting. They're used a lot in the field. These are perf boards. I use perf boards on this. There are going to be some other projects where I use professional PCB boards, where I do have a guy in the area there. I use local PCB manufacturers. They are expensive. I mean, they're not cheap at all. They're like, oh, man. But it's either that or you're going to be spending hours. I spend hours and hours and hours and hours of soldering. So it's either use the perf boards, you jump a lot, or you got to spend the bucks with the PCB boards. I'm not going to discuss PCB, not in this video. There's a lot of little kind of politics, the American versus the Chinese. I'm not going to discuss that quite yet, but you can kind of see where it's going. Okay. Let's talk about this. Yeah, it's a professional solder or perf board. Velcro. I use Velcro. It's very good just to have it stick to the board. It has a nice surface, nice non-conductive. If you bolt it in, there's a chance that you might short it out. So we just place them with Velcro, and it sticks out just great. I'll show you that in the building section. So that's the Velcro. It's kind of expensive. I went to Home Depot. I got it for like $25 for 20 feet. I didn't need that many, but I just grabbed it off the shelf. Let's talk about the capacitor. This is a smoothing 220 UF capacitor. You guys don't know what that does yet, but that's a very important capacitor. At least I think it is. a lot of hobbyists don't use a capacitor, so there's an interesting story behind that. Let's talk about the speed controller. It's just a trim pot. It's just a, to turn it up, turn it down. You can slow it down. It isn't a big deal. We're going to use that. At least I am. But I hope you guys will follow suit. 100K resistors. I just put a whole bunch of resistors there. They're all different values. We'll show you those go along with the buttons. So with the buttons, so you need 2 of those. You need as many buttons. So I have 3 buttons, and so I have 3 100K resistors. The value is so high is because your controller doesn't need a lot of current, and it just needs just a little bit of signal of having on or off switch. Okay, at least that's my takeaway from it. Normal open and push button toggle switches. That's a toggle switch. We're going to use, I use that for the power switch. Just clicks it on, clicks it off. It's either on or off. And then I use normal push buttons. Those are programmed. Okay. I will put a link in the description. I've used normal open push buttons before. On these controllers, I don't know if the Arduino has a more like a listener versus sender. I don't know how their software is these days. I don't know, but I use a different kind of system because I don't think I have that. But there's something like there's normal button, like your computer, like your Java program uses these sort of like these listener type things, and then you put it in there and stuff. And so, anyways, I'm getting off topic. Okay, so that should be your list right there. Don't forget, there's always going to be like little female to female wires. Okay, there's all assortments of wires. You got to jump all that stuff. So take that in mind, and then let's go off to the next section, and I'll see you there. Welcome, everyone. This is the AutoCAD section. We finally got here. I know it's been tough, but we're getting there. Now, what I did on this is a little bit different than most. Instead of having one color, I considered that I had to have multiple colors. So we're going to spend some time with this. Because it's a very busy circuit. You can see that we're getting, compared to the basic circuit and to compare where we're at right now, we're progressing into more complex systems. And so sometimes complex systems, I think all it needs is just a little bit of color. And hope you guys enjoy. So put on your thinking cap. I know there's a lot of wires here, and I'm going to show you how I hook it up, okay? Because this is how I hook it up. And I think I showed on one of the videos of a breadboard, or it wasn't a breadboard, it was a perf board, where I show you hook it up. But here is sort of a way of getting more of a visual. Okay, so let's start with the switches. And we know that each switch has its own function. Okay. So PC0, I have it at that color right there. What's that? Sort of a purple. And the purple, if you follow it, is connected to the button. Okay. But meanwhile, there's power going in there from 3.3 volts. I use, when the battery power comes in, it works better to not use the microcontroller as just a controlling device, not a voltage giving device. So yes, sometimes there is some ports right here. Let me zoom in. You'll see a 3.3 volts, 3.3 and a 5 volts. Sometimes it doesn't have enough power, and there isn't enough power to to enable these circuits, and especially when it's just a battery power. So I let the converters do that type of work. And I think I showed you just a very rough example. I didn't go into that much detail about the buck converters or anything like that, because that's a whole, that's a big mess. That's a course in itself, and I don't, that is very involved and kind of complicated. This signal is a digital out signal. So when the button is pushed, it's going to give you a closed circuit, and it's going to read a signal. So switch 2 will catch a signal. That's going to be the first function, and there's a 100K that is hooked up to ground. That's hooked up to the switch. If it crosses over and it's the same color, it is considered to be connected. If the wire that's a different color, let's say you see that blue and that green, those are not connected. Okay, so that's why for me that saved me a lot of time to explain that. So the green is connected to the green, but the green is not connected to the blue. It's not connected to a different color. Okay, so I repeat, the colors are connected, but the colors, if it's a totally different color, I hope you guys are not colorblind, it is not connected to each other. Otherwise, you're going to have a short, or otherwise the circuit won't work. So I have that. The 100K, the switch does the same thing. It does a different function that's connected to PC1. You see how the blue, we're on switch 3. Switch 3 is connected to the 100K, and it too will read it once it hooks to ground. Okay? Once it hooks to ground. I believe I got that hooked up right. I'm pretty sure it has to be a fully functional circuit. It's a bit strange how that works. Let's go ahead, and the switch 4, it's the same thing. It's 2 is waiting for the switch to be closed. Once it's closed, the circuit will be completed, and it too will sense that it's completed, and it will do whatever the function told to do. I think switch 4 is where the car goes forward and reverse. That's the most important one. Okay, so you guys understand all that. If you don't understand it, please email me. I have plenty of videos where you can email me. That's okay, I understand. If you have anything how you can make the AutoCAD section is better, then email me on that too. That'd be cool. I got this pretty good deal on AutoCAD. AutoCAD smartened up. They usually sell this for. Since I only know 2D, they gave me a good deal. I'm sure they gave other people a good deal. You can get an AutoCAD subscription for $500. I don't know. That's the first time I've ever seen it that cheap. That's for 2D only, though. So and that's all I know. The 3D is actually $2,000, so it's pretty expensive. But I thought that was a steal. If I know. So the switch is connected. Let's go up to the battery. So the battery is connected to the capacitor. The capacitor of a DC circuit isn't open, so these two are not connected. But how I think I showed on the board how the capacitor acts as sort of like a noise filter, and it charges. It basically acts kind of like a filter. It's a filter. It works very well. I highly recommend circuits using it. I got that off of if you're into car stereos, I got that off of something called a lightning cap. So if you guys want to check that out, what a lightning cap for car stereos and how that works. There's a full toggle switch. I have it S1 connected to the ground. It is connected to the ground, and the switch, if that is open, that circuit will not work. When that circuit is closed, everything works. So the electrons cannot go anywhere if that circuit does not work. Okay, so I decided to get an external power, and these are DC to DC buck converters. I think it's an LM2596. I think I explained that. And this is set to 3.3 volts, and that is set to 5 volts. Does everyone and the 12 volts goes in, and 3.3 volts go out. That's all it is. And I think I showed you a little bit of that. I showed you just a simple thing. I just showed you how it worked. I didn't really show you how it really worked because he does use PWM actually, which is kind of interesting to boost it up and boost it down. So he does use this sort of this collapsing and these of the magnetic field in that circuit too. So check that out. Other people have done great on PWM. So the 3.3 volts is connected to the switches, and it's connected to the leveler. Now remember, we had to have a level converter. The reason is, it's probably would have been better if I used an Arduino. An Arduino has a 5-volt output. I would not have to use this, but there's sometimes you may want a super small. If you're a hobby, maybe you want like a watch, or maybe you want some sort of something small to be the controller, and just use other external devices to boost that voltage. Some of the I think the Raspberry Pi may only pump out maybe like a 1 volt or 1.2 volts. They're really small, very tiny, very small amount of memory. So you need a leveler to boost to 5 volts, because there's some of these integrated circuits that require a lot of power. So let's go through that again. So remember that the circuit I have only has 3.3 volts. Remember, it's 3.3 volts. We need to boost it. And I showed that before, that the other, you don't want an indeterminate. So it really does want to see 5 volts. Otherwise, the chip will not work. And I'm talking about the L2DNEH bridge chip. This is a pretty beefy, heavy. This is a very power chip, so it does need 5 volts, not 3.3 volts. So this is a level converter. And on the troubleshoot section, I think I did show you on how I troubleshoot, and I think I scolded, but let's go ahead and move on. Yes, it's grounded. So from here on the left side, this is connected. The yellow wire is connected to the 3.3 volts converter. This is a converter. Notice that the microcontroller, all its job is to do is to basically send signals out. It doesn't provide any power. So, and that's what you want. You just want the brains to do the brains. You want the controller just to control. You don't want it to provide any power if you can help it. And okay, so that is the leveler. On the right side will be 5 volts, but there must be 3 volts on the LVCC, and there must be 5 volts connected onto the other side. So it has to provide power coming in, power coming out. So chip does require power. It doesn't do it by itself, and both sides must be grounded. And there's a lot of grounding. So if you don't ground something, there's a lot of grounding on this circuit. So you can see that I had to solder everything in. It was very busy. I highly recommend that maybe if hindsight was 2020, that I would probably get a professional PCB board. That would probably make it look a little bit neater, but even then you would still need to, that would mean you would have to basically have the whole chassis of the car kind of like one PCB board. You know what I mean? and then just basically plan it. Would that be cool? But I don't want to do that. I don't want to do that. But on some other videos, I do have a professional PCB board, but not on this one. It was a perf board. Let's go ahead and talk. So as we get to the bus out, which is the forward motors and the reverse motors, you can use this chip. This chip has 4 inputs, 4 outputs, and there is two bridges. So you can basically jump. You can jump. Let me take this out. That's kind of dumb. You can jump the wires to one another. Since my car had 4 tires, they didn't have to work independently. They all had to work all at once. They have to go forward all at once, or they had to go reverse all at once, or they had to basically be enabled all at once. If it's an independent system, you would have to not short them out, and each place, each side would have its own individual. But I didn't have to do that. But sometimes it depends on what you're doing. Okay, so let's go on. So PC3 is a level 1. It's connected to the left side is connected to the forward part of the H bridge. The forward part. So 4A is forward. This is also forward. So the motors will go forward at the same time. Okay. The second one is PC4. PC4, I do believe, is the forward motor, but on the rear tires. Okay, forward motor on the rear tires. It too has to be 5 volts. It's connected to 1A. It's also connected to the 1A on the other bridge. Notice everything? Okay. So now next we have PC5. So I didn't want notice that your area on your car is small. So you had to make the most area efficient. I couldn't, so I had to basically use I had to jump a lot of stuff. So I made something called the all reverse. You can do that. So on PC, was it 5, PC5, it too goes to the level converter. The level converter goes from 3.3 volts to 5 volts. It is shorted out to 3A, 2A, 3A and 2A out here. You can do that, and basically all can go at the same time. I could have done that on the forward motors and the reverse motors, but I decided to use up the whole. I might as well use up the 4 channels. I mean, I could have just had 3 channels and it would have worked just fine. The last one is pretty interesting. It is the enable. The enable is not connected to a digital. Remember, it's PWM. We want the enable to be like a dimmer switch. We want it to be the speed control. So we use PWM out to the speed control, and that is connected to PA1. PA1, as you know, on my device is PWM. I think on the Arduino, I think it's like A, or I think it's like D11 or something like that. You can use PWM on the Arduino. I have no idea about the Raspberry Pi. I am sorry, but I only know the Arduino and this one. If you're Raspberry Pi people, come chat with me. That would be nice, so I know what's going on with you guys. I just found the Raspberry Pi to be a little bit too cumbersome. Okay, we're getting off topic. So that PWM is connected to the enable. So it's connected level 4. It goes to 5 volts, and there's the enable on 9, 1, and 1, and 1 up here and the 9 up here at Q1 and Q2 on both H bridges. I wish you guys could, However, now each bridge must have 5 bolts. This is five, so it's 5 bolts. I try to put 5 bolts on there. It just won't work. It just won't work. You're not giving enough power. 5 volts is going out. It's in the orange. Orange is connected to orange. There's a VC1. That is where the 5 volts go. That is the 5 volt logical line. Okay. 5 volt logical line is connected to VC1 on Q2, VC1 on Q1. Okay. That is where the 5 volts go. So okay. Now, the 12 volts, believe it or not, 12 volts, remember that on your device you have to move, there's like a selector switch. You got to select it to, I think it's is it the E5? I think it's the E5 you got to select. I'm not quite sure on the Arduino how you select it, but on this one, remember to read your operator's manual before you connect the higher voltage to your device, otherwise you may fry it. So just be careful when connecting, okay? Because one wrong move, you may have a puff of smoke. It may catch on fire, and next thing you know, you're going to be unhappy. Even worse, if you're dealing with high voltages, it can be deadly. It can even cause death. It can hurt you or even cause death. But this is pretty much low voltage, so the worst thing that can happen, you'll burn up a chip. So let's talk about the 12 volt line. The 12 volt line is in red. That means that's the higher the voltage. That's a real battery. That's a great battery, by the way. It's connected to both 3.3 volts and the 5 volts. It's connected to it's connected to the VIN inside right here. So that's how it works. So it has to be connected to your controller. The controller needs power. There is a way to put 5 volts. I couldn't really get that to work because it does only require a 5 volt. That's what on your USB. That's all it requires. I just go ahead and plugged in 12 volts. 12 volts, however, is connected to the VCC2 line. So this chip will take 12 volts. Okay? It will take 12 volts. Now, there are 4 tires, each tire, and there are 2 chips. On the left side will control 1 motor. On the right side will control another motor. Excuse me. And since we got 2 chips, we got to control 4 motors. So on the motors was kind of be tricky because this is underneath the car. I don't think you have to wire it in there, and it has to connect to the Ys. This is the output. This is the output. The output on one tire. This is the output on the other tire right here, and it's the Y section. So the Y is over here, the Y is over there. Okay? Am I let me think. Okay. So that should be good. Oh, okay. Then there is the speed control. The speed control gets 3.3 volts coming in. That's all it needs. It doesn't need to be powerful. This is the knob right. It's connected to PA0, which is sort of the same thing as the Arduino A0, and it is connected to the analog in. Okay, so that's about it. I'm gonna let's go ahead and I want you guys. I'll give you sort of a big picture view, which you guys are gonna have a hard time. So let me go take it in chunks. And I'm just going to slow it down. And I take a screenshot, sort of like tape it together or something like that. Just kind of tape it together. And so here you go. So here's that one. Okay. I'm gonna go slow. Here's the Arduino. I mean the Nucleo or the embed. It doesn't matter. Okay, and then we're gonna go in closely. Okay, this is the leveler. Okay, and believe me, this was pretty challenging. These are the motors. See how it's all connected in, color coordinated. Okay, okay. There's the green, and these are the buttons. Okay, I think I've said about everything. That's ground. Okay. All right, and there's the capacitor. Capacitor is optional. You don't have to have it, but I highly recommend it. I believe it's quite helpful. All right, so that will do it, folks. Hope you guys enjoy that section. If you hope you enjoy that set, you guys are a quiet bunch. You guys don't say much. And I will see you on the next section. The next section should be code talk. Holy shit. Okay, so we're going to start again. Take two. All right. So welcome to the Code Talk. This is where we discuss, I literally comment my code as we speak. I did comment them anyways. This is the way I comment. Maybe right, maybe wrong. We'll find out. So you see, I've been working on this for a long time, since 10/21/2025. So it's already December. So I've been working on this for quite a while now. It took, there was a lot of interruptions. Family came over. I had to do a road trip. I had to go see my brother and all that stuff. So, family comes in and, as Elon Musk says, engineers' worst enemy is social life. and and it's funny he said that. I'm not a huge fan of Elon Musk, but he is kind of right. I can't get this. Everybody calls me and gets my stuff done. So I have an email, andrewchen80@gmail.com. Just use a Gmail. I used to have a phone number, but I'm a bit like Mad Max on the phone. I just go nuts. So if you've seen the Wolf of Wall Street, I'm a bit like that guy. Oh, the market's going. So anyways, I will try to work on that. So analog in is this is the analog in. So analog is the motor speed, and this is where we control the motor speed at PA0. So go ahead and check that out. Try to find out your analog in on your own device. I think there is the same thing on the Arduino. It's almost the same thing. Digital in, button 1. I think there's the same, anyways, just translate it, guys. Also, there's the PWM out. I call it enable motor. That is basically you need, as analog in, you must do PWM out. So it has to basically translate. Otherwise, it's just going to be an off and on, like digital in, like what it says. Okay, and the bus out is my mode. I put it into, when you do a bus out, you turn it into one device, kind of like one port, which is pretty cool, because now you can identify these ports a bit cleaner, and you can use AND addition, I think, or something like that. Sometimes I forget these terminology. Anyway, so I got PC3, PC4, PC5 is going out. Those are the motors. I have the right motor. I got it all kind of daisy chained. So there's the right motor, the left motor, and all reverse. Okay. There's flow. I timed 5 seconds, so I just want the car to go for 5 seconds and then stop for about 5 seconds. I don't want the car to just keep going. Because I'm probably going to put this on the street, and I don't want to be chasing after it. Cars running over it or something like that. I want to just do it in a short area and pick it up. Frequency, as you know, I put it at 50. This is to 1 over 50. I think it's 0.020, something like that. That's 1 over 50. That's the time. So we want the period, of course. Period is the time of when it, you got to put the period for the computer knows to when it's supposed to be on and when it's supposed to be off. And there is, the period is like the parameter, and the in order for these lot of this functions to work, even like the robotic functions, it needs a parameter. So to go right and left, let's say on my next videos, but that's going to be a while now. It's going to be a while where we use servo motors. You use a parameter where it goes left and where it goes right, and so I then right here, enable motor period. This is your setup. So right between the main and the while loop down here, not that while loop, the while true, okay? There's a while true. This means the button goes on forever and ever and ever. And so you want your setup and your stuff it can be here. But it works, sometimes it works a little bit better in the in the main area. This is sort of the global area. Sometimes it just depends. You may say, well, how come it doesn't work? Well, sometimes it needs to be in the main, or sometimes it needs to be global. It depends on what you're doing. And I guess through experience, you kind of know where to put it. So I'm getting a little bit more experience in this. So the while true, this is where most of your code goes in. You can, and that's the end of the bracket right here. Okay. Let me see if I can delete all this good stuff right here. Now let's go ahead. I have 3 buttons: button 1, button 2, button 3. The first button, I wanted it to be pretty simple. So I just wanted to be on for 5 seconds, just go and stop. You can, PWM could have been used right here. I just didn't use it right here. But if you want to use PWM, that'd be great. So my motors, so how this works is kind of funny. When you push the button, it cycles through. So it's kind of like your washing machine. You push your button on on the washing machine, and then it just cycles through. And sometimes you can't turn off the system until it cycles through. So it's always best, and there's many devices are like that. So the else loop is basically the device of where it spins. So I have a for loop in here. So when when you push the button, and please check out some of my old videos on this code right here. It'd be helpful. What it does, it signs it to the number 3. So it starts off as 0. It starts off as 0, and basically, did I ever start off as 0? I think I did. Oh no, it just enable motor equals 0. Okay, I could probably do that. I'm going to do my code so it starts up as 0, and basically you push a button, and when you push a button, it will go through this else loop. It will sign it 3. Then it will wait until it's over, and then it will stop. Okay, and then it will go to the if loop, and the if loop will say, oh, there's a 3. Is a if button if well, when the button excuse me. So first you push the button. Okay, when it equals 0, that is when it is basically the potential is always going to be 3.3 volts. when you hit it, it goes to 0. Current flows, but the potential that that is 3.3 volts now goes to low. Okay, so it goes to low. When it goes to low, it's going to say, is it 3? And they're saying, no, it's not 3. So then, okay, well, my motor's equal 3, so 3 or 3, it assigns it to 3. Oh, it assigns it to 3. So it assigns it to 3, and then it works. It works. Then it goes back, and then it assigns it back to 0, so it stops. It stops. It pushes the button. So it goes, is it 3? Oh, it is 3. Okay, well then turn it off. Okay, while button is 0. So this is very important for this button. The second button it's the same thing, except now we have a motor control. It's called enable motor dot write, the motor speed. So the motor speed, what you put in is what you get out. So you write the motor speed, which is your input. Your enable motor is your output. So whatever your output is, so it's going to be like, oh, okay. And so it makes the enable part of the chip, which I discuss on the next time, a bit. The time is the same, but the voltage is the same. Excuse me, but the time is different. So it could be a 50 to 50. We'll discuss that a bit more. And so you get it till the time will just be, you can move it, you could dial it down till you just get time for just a split second, and then the rest of it's off for a second. So it moves very slowly. And that's how you use the speed control. Okay, now the third one right here is we enable the reverse. So you push the button on the third button. It's right here. It's going to say, okay, you push the button. All right, let's sign it to 4. Now, when you sign it to 4, okay, when you sign it to 4, I'm going to have to write this down. When you sign it to 4, let's go back to your bus out motors. So the first one right here is 0, 0, 0. The first, it's backwards to what you think. The first 0 is the least significant digit. The last on the right is the most significant digit. I know we're taught going from left to right is the most significant digit, but you gotta basically expand your mind and go in reverse. Okay, so if I put a 3, you notice that that's a 3. Why is it a 3? It's because I decided to put my right motor and my left motor to work at the same time. Remember, I got tires. They all have to work at the same time. So that is a 110 going, I know, going from left to right, not right to left. Okay? So you got to be flexible, folks. I know you're taught from going, but you got to be flexible. Gotta like, maybe, you know, take some mind altering drugs. You got to like think out, you got to think outside, you know what I mean? You got to think about how this is supposed to go. So that is a 3 if the least significant digit is on the left side moving to the right. That is not a 5. Okay? Now, so I said that is a 3. So that's okay? All right, just want to make sure. I know you guys are going to be staring at your phone right now, but that's fine. There is a 3 right here, and there's a 3 right here. So that is assigned a 3. That means I want the motors to be 3, but the button, it will work. And it will work if the button is 2. Oh, my bad. That's not supposed to be there. I'm sorry. That's not supposed to be there. Because if I put a 0 there, then it's always going to be a 0. So No, that's not supposed to be there. Okay, because we have it on the best side. I was right the first time. Okay. Now, if I want it to be a 4, so this equals 3. And if I want it to be a 4, LSD is here. Okay, and or actually not LSD, I'm sorry. It'd be B, LSB, not LSD. And that's least significant digit, not lysergic diethylamine acid, where hippies, they go crazy and they're staring at the wall and shit. Okay, most significant bit. Okay, and that is equal to 001, but remember that it's going, so that equals 4. Okay, I'm sure okay, so it's just put it in reverse, okay? So now that equals 4. It will run until this will run, the else will run, and then it will turn off. It will go back to it. It'll say, oh, is it a 4? Oh, well, then turn me off. Okay, because it basically, you have normal open push button switches. So the moment it hits, it's going to engage it, but then it's going to go back to its state. So it's when it goes back to its state, it's just going to turn off. And now I have it. Now I have the first part on the for loop is I have it to write the motor speed. So I got it going in reverse at first, and then when it goes to the next, then I turn it off. My motors equals 0. I engage it to 3, which is going forward, and then I write it again. Now I write it, the motor speed, and I have it at a time. My time is 5 seconds. You can always change this time right here. So if you want to go for 10 seconds, 20 seconds, 2 seconds, half a second, whatever, how many seconds you want. If you want to have a race like a drag race, and it's going to be about 10 seconds long, this is it right here. So, okay. So hopefully you guys understand that. Hopefully you guys understand that. I really do. And let's go to the proof section. It's a bench proof, and I hope you guys will enjoy that too. I'll see you there.
Welcome everybody, welcome. I'm very excited. The old man is at the, looks like he's fired up. He's fired up. Okay, so this is the car right here, and I worked pretty hard on it. It's hopefully it's not gonna mess up, because sometimes the wires are, it's not that everything's not correct, it's the wires are kind of, the port wires could get kind of bored out. They kind of get open up. So they don't sometimes connect that well. If everything was soldered, I'd be like, oh yeah, this is perfect. But this is a prototype stuff. So let's go ahead and look on top, okay? Look on top, we're looking at it. All right, you see those are pretty cool. We got 3.35 volts. We got everything there. I'll show you that in detail in the next video, but right now I just want to get this car going. Okay, so the first button. There it goes. Look at that thing spin. Look at that. That's the first one. It's going as fast as it can. Okay. Let me get around here first. Okay, and okay. All right, we're still live. We're still live. All right. I'm knocking stuff over. I'm like a bull in a china shop. The second button, a little bit of speed control. See him messing around with it. Okay, let's get that up. And the third one, there it goes. There you go. You see it go backwards in reverse? Let's go ahead and watch that one again. Let's go ahead and watch that one again. See, it goes backwards. It looks like it's staying still. It's going so fast. I want to see how this thing looks like on the street, you know. Then it goes back. It looks like, look at those rims, baby. Look at those rims. All right. Let's put this on the street. And then it stops. Okay, see, it stops, and so I don't have to chase after it. Okay, so let's take it on the street. Okay. I am fired up. Recording? Yes, we are. Ready?
Mm-hmm.
Get the car.
Okay.
Car. I don't know why it turned.
Oh no.
You got the car?
Yeah. Okay.
All right.
Okay.
No.
What?
I was supposed to get the fucking candy bar.
Oh.
I told you that like 3 times, but that's okay. We'll do it again.
Okay, I didn't understand what you were doing.
Okay, so go ahead and we'll film it again.
Okay.
On the next. Make sure you focus on me. Andrew and Bard's show.
Okay, so if you enjoy my videos, thank you for. I appreciate the people who subscribe. Thank you, and I appreciate your viewers. We're getting a lot more viewers than we are subscribers. That's okay. We're still a small channel. I don't mind being a small channel. You can get away with a lot of stuff. We're on our way to 100 subscribers. 100 subscribers, I will get a YouTube coach. A YouTube coach is great. It will help me motivate me. It will criticize the way I do things, or even encourage the way I do things. And I appreciate people viewing. So if you haven't subscribed, please subscribe. Put a thumbs up. Put a comment down. Now, before I begin, okay, bear with me, folks. I know this is boring, but so 100 subscribers are huge. It doesn't mean much to the viewers because it's just a little button, but it means a lot to YouTube and me. You don't get paid unless you get 500 subscribers. I know you guys subscribe to silly stuff that's funny and stuff like that, and hot yoga videos where you see a woman's body. But okay, so that means .com. This is my email address. Please do not abuse it. Constructive criticism is nice. There's people out there. I appreciate it. I appreciate all the views. I will consider. I will consider anything. Try not to peddle. Don't peddle Bitcoin. Please don't peddle. I know everyone's in this peddling culture. I mean, I peddle. I mean, so. But please don't. If you got any ideas how to make the channel better, go give me an email. I don't do DMs yet. It's because I need a separate phone. I need a private phone. And I need a business phone. I don't have a business phone. I just have a private phone right now. So Andrew Chatten, CHATTEN 80 at gmail.com, and I will do the best I can within to answer is just say hello, Engineering Bart, or hello, Andrew. I saw your stuff on YouTube. This is for YouTube stuff. Appreciate it. And